All right, let's get right into this. We are going to explore a really fascinating mystery that's sitting right at the heart of the internet. It involves a massive, and I mean massive, online library and a piece of technology that security experts consider completely, fundamentally broken. It's an incredible story about how a totally obsolete tool became the secret key to a modern revolution in accessing information. So if I asked you that question, what would you say? You'd probably think of, the Library of Congress or maybe the British Library, but there's this other contender, this enormous shadow library called Anna's Archive. It has no physical shelves, no buildings, but it claims to be a search engine for preserving basically all of humanity's written knowledge. And for the people who use it, it is an absolutely indispensable tool. I mean, just look at how this Reddit user puts it. It's a haven, a way to get your hands on information that would otherwise be way too expensive or just plain unavailable. For a lot of folks, it's seen as this great equalizer. Okay, so that right there brings us to the central puzzle. This whole thing isn't just about the ethics of sharing files, it's really a technical detective story. What is the secret sauce that lets a website index this vast library of digital books without actually storing a single one of them? Well, the answer, and you might find this surprising, it isn't some brand new, cutting-edge technology. Nope. It's a really clever use of an old algorithm, one that goes all the way back to the early 1990s. What's really cool is how we find the answer. It's hiding in plain sight. On the site's own subreddit, a user asks this very specific question: how do I get a book's title if all I have is its MD5 hash? And boom, that's our key, the MD5 hash. They're not talking about titles or authors, but these unique codes. So what on earth is an MD5 hash? Well, think of it exactly like a fingerprint, but for a digital file. The MD5 algorithm takes any file, a book, a picture, doesn't matter. It runs all of its data through this complex mathematical blender, and what it spits out is a completely unique 128-bit identifier. And this is exactly what that fingerprint looks like. A 32-character string of letters and numbers. Now, it looks random, but it's not. It is directly calculated from every single bit and byte of that file's contents. And here's the magic part. If you change just one period in a 500-page book, the entire hash value changes completely. Now, the process itself is pretty complicated, right? It involves all these rounds of operations and different chunks of the file's data, but the most important design principle here is that it's a one-way street. You can't take that hash and somehow rebuild the original book, but you can take the book and check that it produces the exact same hash, which proves it hasn't been altered one bit. But this is where the story gets really, really interesting, because here is the great paradox. If you ask any cybersecurity expert on the planet about MD5, they are going to tell you one thing: it is dangerously obsolete. It's broken. And listen, this isn't a new opinion. For well over a decade, major security institutions have been sounding the alarm. The Carnegie Mellon Software Engineering Institution flat out called it cryptographically broken and totally unsuitable for any kind of security application. And the history of MD5 shows you exactly why. I mean, the cracks started showing up way back in the mid-90s. But the real crisis hit in 2004, when researchers proved they could intentionally create two totally different files that produce the exact same digital fingerprint. That's called a collision, and for a security algorithm, it is a catastrophic failure. And it led to real-world attacks, like faking security certificates and even forging a Microsoft software signature for the Flame malware. But then, you look in a totally different field, and you see this. In the world of legal tech and digital forensics, MD5 isn't described as broken at all. It's called the foundation of a defensible process. So, how can it be both a dangerous liability and a foundational tool at the same time? Okay, so here's the crucial point. The entire paradox boils down to the difference between security and integrity. MD5 is broken for security because a bad guy can deliberately engineer a malicious file to have the same fingerprint as a safe one. But it's perfect for identification and integrity because if a file is unintentionally changed, say it gets corrupted during a download, its hash won't match anymore. It's also amazing at finding duplicate files in a gigantic data set. And that perfection for identification, well, that is precisely the loophole that brings us right back to our ghost library, Anna's Archive. You see, the site is brilliant. It doesn't need to store a single book. Instead, it just stores the digital fingerprints, those MD5 hashes, and the metadata, like the title and author, which is often public info anyway. It basically acts like a massive card catalog.
It tells you a book's unique ID and then points you to other places on the internet where you might find a file with that exact same fingerprint.
As you can probably imagine, this has kicked off a pretty fierce debate online. The main argument against the site is simple: it's direct. Just like this user says, it helps people pirate content, which they see as stealing. From this point of view, the fancy technology doesn't matter. The result is theft.
But then, here's the counterargument, laid out here by another user who says they're a copyright lawyer. They argue the site itself isn't hosting the material, it's just indexing it and linking to it, which makes it function just like a search engine. I mean, Google links to all kinds of stuff without being held responsible for what's at the end of that link, and that is the legal tightrope that this whole operation walks on.
Now, this whole situation, it doesn't exist in a vacuum. It actually taps into a much bigger, decades-long tension between controlling information on one side and the drive to make it universally discoverable on the other.
For decades, the official world, we're talking libraries, archives, academic institutions, they've been on this exact same mission. They created universal languages for data, these metadata standards like Dublin Core, and launched huge projects like the Open Archives Initiative. The goal has always been the same: make knowledge easier to find, easier to share, and easier to connect across any system anywhere in the world.
And what's so wild is that shadow libraries take this exact logic, the logic of indexing, of metadata, of discoverability, and they just apply it to a different set of content. In a way, they're like a dark mirror of the formal library world, using the same powerful ideas of organization for a purpose that lives in this deep legal and ethical gray zone.
So, what you should really take away from all this is the incredible dual nature of technology. The very same tool, this humble MD5 hash, is used in a court of law to prove that evidence is pure and hasn't been tampered with, and at the exact same time, it serves as the central gear in the engine of a massive shadow library.
And that leaves us with this one last really big question. This isn't just about one website or one so-called broken algorithm. It's a case study in a fundamental question of our time. When a tool is powerful enough to be both foundational and disruptive, who gets to write the rules for how it's used? The answer to that is going to define the future of information